In this video, we will learn how to find the reference angle for a given angle. Now, this is one of our special angles. Pi over 4 is a special angle, so it's going to be relatively easy to do because we know our reference angle is going to be pi over 4. Alright, so that's it. We can just look at the denominator and know it's going to be pi over 4. Now I can back that up with a nice picture to sort of prove it. So look at my unit circle, and I'm going to draw some pi over 4s for you. So when I split it down the middle, alright, my top half is pi. Whoops. Boy. My top half is pi. So far I have pi over 2s. If I split it again, then I have pi over 4s happening. So these are now each pi over 4. So if I start from a standard position like so, and now I'm going to go 9 pi over 4. So watch me go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so that's going to put me right here as the terminal side. Now my reference angle is this, and of course it is pi over 4. Now things get more complicated when it's not a special angle. Alright, take a look at number 4, negative 22 pi over 9. Now pi over 9 is not a special angle, and pi over 9 is not going to be the reference angle. The key is to figure out what quadrant we're dealing with. And to do that, it's going to be helpful to find the decimal for 22 over 9. So 22 divided by 9 is 2.4 repeating, so approximately 2.4. Alright, that means that this fraction is approximately equal to negative 2.4 pi. So let's use that to help us to help us figure out which quadrant we're going to be in. So let's go ahead and draw our unit circle like you do. Okay, so as always we're starting off in standard position. Now because I'm traveling in the negative direction, that means I'm going to be going clockwise. Okay, and I'm looking for negative 2.4. Now negative 2 pi is a full revolution. So if I go like this and all the way back to here, so far I've gone negative 2 pi. Now I need to go another 0.4 pi, alright, before I am finished. Now remember that pi is a semicircle, so every quadrant is half of pi. In other words, 0.5 pi. So far I've gone negative 2 pi. If I went one more quadrant like this, this would be negative 2.5 pi, right? Because it's an extra half pi. And, well, that would be too far, wouldn't it? Because I only want to go negative 2.4 pi, not negative 2.5 pi. So that means I'm going to be somewhere in this quadrant, alright, since negative 2.5 is too far. So I'm going to go ahead and draw the terminal side, not quite making it to negative 2.5. Okay, so this is the idea. Alright, so just clean this up a little bit. So now I have drawn approximately negative 2.4 pi, but let me go ahead and write it the way we originally did. So right here is my negative 22 pi over 9. Okay, approximately negative 2.4 pi. Now the reference angle is right in here, and I'm going to use R to represent this reference angle. Alright, it's just the gap between these two. And to be clear, remember when I went 1 revolution, I had gone negative 2 pi. Alright, I wrote it here, but let me make it more clear by putting it on this border right here. So 1 revolution back to the start was negative 2 pi. But if I went beyond that, then I arrived at negative 22 pi over 9, because that's negative 2.4 pi approximately. Anyway, the reference angle is the gap between these two. So to find how big it is, I need to subtract. So I just need to subtract, and at this point I can really ignore the signs if I want to, and just do 22 pi over 9 minus 2 pi. Alright, the reference angle should be 22 pi over 9 minus 2 pi. Alright, I'm just subtracting these two. The reference angle is always going to be positive. Alright, it's just like a size. So I can just deal with the positive versions here. And of course I'm going to need these like denominators to make this happen. So let's go ahead and do this as 9 over 9. So I'm really going to be doing 22 pi over 9 minus 18 pi over 9. 22 minus 18 is 4. So 4 pi over 9. So this is going to be my reference angle. Alright, and that is how you find the reference angle when you don't have a special angle to deal with.